People hear me?
Yes, sir.
Right. Okay, right. So today we are going to discuss the 24th paper of the in paper discussion. Frame 24. Right. So in this paper, I'm focusing on discussing some chemical calculation questions, very easy calculation questions. So let's see how we can complete these questions. Some easy questions are there. Okay. Right. So let's go one by one. Question number one. In the question number one, what they have given, the dry mass of a precipitate barium dichromate, BaCr2O7, formed when 200 cubic centimeter of 0.2 moles per cubic decimeter barium nitrate is mixed with 300 cubic centimeter of 1 moles per cubic decimeter potassium dichromate. So they have given two solutions, right? Remember, they have given two solutions. So the first solution is they have given that 200 cubic centimeters, 0.2 moles per cubic decimeter, barium nitrate solution, BaNO3 twice. Barium nitrate aqueous solution, right? And you are going to mix another solution with this solution. They have given that is 300 cubic centimeter, 1 moles per cubic decimeter, potassium dichromate solution, K2Cr2O7. So this is it, potassium dichromate solution. Right. And they're asking, what is the dry mass? Remember, they're asking the dry mass of the precipitate barium dichromate, BaCr2O7. So remember, if we can write down draw the precipitate. So this is the precipitate we can obtain, barium dichromate, BaCr2O7, barium dichromate. They're asking what is the precipitate, what is the mass of this precipitate? First of all, you have to identify what is the chemical reaction taking place in it. Barium nitrate, BaNO3 twice, is reacting with potassium dichromate K2Cr2O7. Right? And they have given that barium dichromate is the precipitate. So therefore, we can have barium dichromate, BaCr2O7, and the next one should be potassium nitrate solution, KNO3. Right? So this is the chemical reaction taking place when you mix these two solutions. Right? And now we have to find out the mass of this precipitate barium dichromate, BaCr2O7. Okay. First of all, we have to balance the reaction. So how many potassium atoms are there? In the left hand side, there are 2. Therefore, let me put here 2. Since there are 2 nitrates in the left hand side, now you can see automatically 2 nitrates are there in the right hand side also. So we can understand that the reaction is balancing automatically. Right? Now, we need to find the mass of barium dichromate. How we can find the mass of barium dichromate? Very easy. Because we know that the amount of barium nitrate that you mix with the concentration, And you know the amount of potassium dichromate you mix with the concentration. Concentration and the volume is given. When you are given the concentration and volume, you know how to calculate the number of moles. The famous equation is what? C equal N over V. C equal N over V. Concentration is equal to the number of moles divided by the volume. You know that, right? Therefore, we can get the number of moles from this equation N equals CV. Concentration multiplied by the volume. What is the concentration? What is the barium nitrate concentration? They have given that is 0.2 moles per cubic decimeter. Moles per cubic decimeter. And what is the volume? Volume is 200 cubic centimeter. You can write 200 cubic centimeters in cubic decimeters. How is that? We know that 200 cubic centimeters is equal to 0.2 cubic decimeters. Then cubic decimeters per cubic decimeters will cancel out. Then the number of barium nitrate moles will be 0.0. Right? So these are the barium sulfate moles that we have added in this solution. And then we can find out potassium dichromate moles. Right? Look at this one. Potassium dichromate concentration is given as 1 moles per cubic decimeter. And the volume is 300 cubic centimeter. That means 0.3 cubic decimeter. Easily you can identify the potassium dichromate moles are 0.3 moles. Right? Barium nitrate moles are 0.04. Potassium dichromate moles are 0.3. Remember, in the solution there are 0.03, 0.04 moles of barium nitrate, 0.3 moles of potassium dichromate. Then you have to find out the mass that you will obtain as barium dichromate, BaCr2O7. Now you have to understand here, the amount of barium nitrate and potassium dichromate, they are not equal. The stoichiometry ratio between barium nitrate and potassium dichromate is 1:1. Then you should understand how much of barium nitrate will react with how much of potassium dichromate. According to the number of moles that you obtain, the highest number of moles will be potassium dichromate, K2Cr2O7. And barium nitrate is 0.04. Then you have to understand 0.04 moles of barium nitrate will react with 0.04 moles of potassium dichromate. So we can write down the number of reacted moles in this way. Look at this one, very easy. I'll write the reaction again, barium nitrate, PaNO3 twice. With potassium dichromate K2Cr2O7 forming barium dichromate BaCr2O7 and potassium nitrate. In order to balance the reaction, we can put here. So initial number of moles, initially how much of moles you have added? How much? Barium nitrate is 0.04. Potassium dichromate is 0.3. Then we can calculate here how much of reacted moles from each. Neither. We can calculate how much of moles that is going to react from each. Look at the ratio. Stoichiometry ratio between barium nitrate and potassium dichromate is 1:1. That means you can understand 1 mole of barium nitrate is going to react with 1 mole of potassium dichromate. According to the stoichiometry ratio, we can understand the limited reagent is barium nitrate. Therefore, the reacted moles will be 0.04, 0.04 from each. You can understand potassium dichromate is in excess, but barium nitrate is in less. So therefore, barium nitrate is considered as the limiting reagent. Barium nitrate is the one who going to decide how much of moles that is going to react from each. So therefore, 0.04 moles of barium nitrate will react with 0.04 moles of potassium nitrate. And then, so the remaining moles, if you want to find out the remaining moles, for this calculation, remaining moles are not necessary. But we can understand barium nitrate is completely consumed and potassium dichromate will be the difference of this one. So the difference of this one will be 0.26. Now, In this question, our target is to find the mass of barium dichromate, right? That means we need to find how much of barium dichromate moles formed, right? So here we can write reacted and formed, right? Reacted and formed, because these are products. So products are formed from that reaction. So the number of barium dichromate moles produced from the reaction is 0.04 again, because number of moles are 1 according to the ratio. Ratio is 1:1:1. So number of barium dichromate moles formed here is 0.04 moles. Therefore, now we know that barium dichromate moles are 0.04 moles, right? Number of barium dichromate moles formed here is 0.04 moles. If you know the barium dichromate moles, can't you find out the mass of barium dichromate? They have given the informations, they have given the relative atomic mass of each atom. So therefore, we can find out the molecular mass of barium dichromate, BaCr2O7. Barium is 137. Chromium is 52 into 2. Plus oxygen is 16 into 7 grams per mole. Right? Now do the calculation and find out the molar mass of barium dichromate. Then you will obtain here 137, here 104, and here you will have 16 into 7. 16 into 7 will be 42. 2 here, 4 here, then 7, 11, 112. Get the summation. Then you will obtain here 13, 1, 5, 353. 353 grams per mole. So this is the molar mass of barium dichromate. So if you know the molar mass, if you know the number of moles, can't you find the barium dichromate mass? Easily you can find the mass of barium dichromate. Barium dichromate mass will be mass of barium dichromate, Cr2O7. It will be number of moles multiplied by the molar mass, 0.04 moles multiplied by the 353 grams per mole. Per moles will cancel off. Now do the simplifications. 353 multiplied by 4. 12, 1 here, 21, 2 here, 12, 14. How many decimal points? 2 decimal points. So therefore 14.12 grams is the mass of barium dichromate. Okay. So this is the first question. Any doubts? In the answers, they haven't given the correct answer either. 14.12 gram is not given. It's okay, fine. Doesn't matter. So let's take that one. The correct answer is 14.12 gram. Here you should know how to do the calculation. That's all. Right. Shall we go for the second question? Shall we move to the second question? Second question. The second question, they have given that volume of 0.5 moles per cubic decimeter sodium XO3, Na2XO3. The compound is given in symbolized form, Na2XO3. They haven't given the volume, but they have given the concentration is 0.5 moles per cubic decimeter, which react completely with acidic KMnO4. It's reacting with acidic KMnO4. They have given the concentration is 0.1 moles per cubic decimeter, and the volume is given as 20 cubic centimeters. 20 cubic centimeters. So this is a redox reaction because they have given that here XO32 minus. In this reaction, XO32 minus is going to convert into XO42 minus. So just remember, when you look at this XO32 minus and XO42 minus, what you can remember actually? Exactly what you can remember. Sulfite and sulfate. It's look like sulfite and sulfate neither. SO32 minus and SO42 minus. It's look like SO32 minus and SO42 minus. Neither. But anyway, since they haven't mentioned what is the element capital X, we cannot take that one as, we cannot consider that one as sulfur. Let's assume it is sulfur, and from the given information, let's continue the calculation, right? So here they're asking how much of volume that is going to react with acidic KMnO4 from sodium XO3. How much of volume? They're asking to find the volume of sodium XO3, Na2XO3. Is a redox reaction. So therefore, first of all, we should be able to write down the redox reaction, right? So let me write here MnO4 minus is going to convert into Mn2 plus in acidic medium. So that is very common knowledge, right? We know about that one. In acidic medium, MnO4 minus is going to convert into Mn2 plus. That's going to reduce, right? Manganese oxidation number is +7 here. Manganese oxidation number +2 here. +7 to +2. The how many electrons that is gained by manganese? 5 electrons, right? 5 electrons. And here they have given XO3 minus, right? XO32 minus. XO32 minus is going to convert into XO42 minus, and definite byproduct is water. Always definite byproduct is water. Now, look at the oxidation number of X here. When you calculate the oxidation number of X here, that will be +4, isn't it? And here, when you calculate the oxidation number, that will be +6. So +4 to +6, oxidation number is increased by removing 2 electrons. Oxidation number is increased by removing 2 electrons. Here, oxidation number has decreased by gaining 5 electrons. Now we know that balancing redox reaction means we have to equalize the total increment and decrement. So therefore, I will multiply this one by 2 and this one by 5. Here 5, here 5, here 2, and here 2 as well. Okay, here 2 as well. Right, now let's try to balance the reaction. How many X atoms are there? 5, okay. How many manganese are there? 2, done. And number of oxygen atoms are not going to change hereafter in the left-hand side. Number of oxygen atoms in the left-hand side is 15 plus 8, 23. Oxygen atoms are 15 plus 8 here, 23. We have already 20 here, therefore let me put here 3. Now, how many hydrogen atoms are there in the right-hand side? 6. So therefore, let me put here 6 H pluses. And if you want to check whether the equation is balancing or not, you can calculate here +6, -10, -2. So the summation will be -6. And here also, the charge. So this is charge, okay? I'm calculating the charge of both sides. Charge in the right-hand side is also 2 into +2 is +4. Here 5 into -2 is -10. So -6. So that's confirmed that it's confirmed that the equation is balancing properly. It's confirmed that the equation is balancing properly. So this is the equation. So this is the redox equation. Now, they have asked us to find the volume of sodium Na2XO3, right? So they have asked us to find the volume of Na2XO3. So therefore, let's see how much of dichromate permanganate moles reacted. Number of moles MnO4 minus reacted here. Concentration is 0.1 moles per cubic decimeter, right? And the volume is 20 cubic centimeter. That means 20 into 10 to the power minus 3 cubic decimeters. Per cubic decimeters will cancel out. Then the answer will be 2 into 10 to the power minus 3 moles. Look at this one. These are very small calculations, right? Very easy calculations. Concentration multiplied by the volume, that is number of moles, right? And we know the stoichiometry ratio between permanganate and XO3 minus, right? What is the stoichiometry ratio? MnO4 minus and XO3 2 minus ratio is 2:5. Then can't you find the number of XO3 minus moles? Can't you find XO3 2 minus moles? XO3 2 minus moles will be, right? For 2 permanganate, there will be 5 XO3 minus. Then for 2 into 10 to the power minus 3 moles, how much of XO3 2 minus moles will be there? 2 will cancel off. Then easily we can find out XO3 minus moles, XO3 2 minus moles will be 5 into 10 to the power minus 3. 5 into 10 to the power minus 3 moles of XO3 2 minus will be there. Okay. So the number of of XO3 2 minus moles will be what? 5 into 10 to the power minus 3 moles. Right? So what we have done, we know that Na2XO3 is reacting with acidic KMnO4 from the redox reaction. So first of all, I have obtained the redox reaction properly. MnO4 minus is converting to Mn2 plus. We know that one. XO3 2 minus has converted to XO4 2 minus. They have given that in the question. And we know that this is in the acidic medium, therefore H plus is added. Water is definite byproduct. And we can balance the reaction in this way. We know how to calculate the oxidation numbers, and in this way we can balance the reaction. By using the balanced chemical reaction, we can obtain the number of permanganate moles, MnO4 minus moles. If you know the manganate moles, according to the stoichiometry ratio, we can obtain the XO3 2 minus moles. So these are the XO3 2 minus moles. If you know XO3 2 minus moles, right? If you know the XO3 2 minus moles, what will happen? We can find out the volume because we know the concentration, we know the volume, then we can easily find out the volume. We know the concentration, we know the number of moles. We know the number of moles and the concentration, we can find the volume, right? So let's find out the volume. What will be the volume? So volume of Na2XO3 will be, what is the volume? Number of moles, 5 into 10 to the power minus 3 moles divided by the concentration is 0.5 moles per cubic decimeter. Moles will cancel out. Then here answer will be here 0.5. So therefore 10 into 10 to the power minus 3 cubic decimeters. That means 10 cubic centimeters. So the volume of Na2XO3 will be this one. This is the answer. So for the second question, answer is first one. Second question, answer is first one. Okay. Anyone didn't understand here? Amani, Devindi, Afsha, Mariam, Ranjula, Zara. Do you have any doubts? Anything? Understood. Please put your doubts in the chat box, okay? No. Zara, understood? Right. Okay, good. Now let's go for the third question. Third question is given that if you want to copy down something, quickly copy down, okay? Very easy. This question is really easy. Nothing difficult. This is completely regarding the redox, right? Okay. We have learned everything regarding the redox. So redox calculations and concentration volume changing, right? You know how to calculate the concentration if you know the number of moles and volumes. So everything we learn, right, in chemical calculation. Normally, you will get some MCQ questions from chemical calculation for your examination paper as well. You should be able to answer for them within limited time period, okay? Right. Done. Now let's go for the third MCQ. In the third MCQ, they have given 1.6 grams of carbon dioxide and 1.08 grams of water release when hydrocarbon is burned. Empirical formula of the hydrocarbon. Okay, right. Let's see. Okay, I'm moving to the third question. So in the third question, they have given that a hydrocarbon is burned. Let me consider the hydrocarbon is CXHY. I don't know the correct formula of the hydrocarbon. So therefore, let me consider a CXHY is burned in oxygen. Then carbon dioxide and H2O is formed. Right? And if you want to write down the balance reaction, we have learned this one in chemical calculation. CX and this is H. How many hydrogen atoms are there? How many hydrogen atoms are there? Y. So therefore, we can write down here Y over 2. Because when Y over 2 multiplied by 2, then again you will obtain Y. So therefore, the number of hydrogen atoms in the both side will be Y. Now calculate the number of oxygen atoms in the right hand side. This is 2x and this is Y over 2. And here already we have 2, right? Here already we have 2. So if we have 2, then what we have to put here, x plus y over 4. X plus y over 4. X plus y over 4. Okay. Then now equation is balancing. You can understand that equation is balancing in this way. They have given that the mass of carbon dioxide obtained is 1.76 grams. And the water obtained, H2O, is 1.08 grams. Okay. Now, how we can find out the empirical formula? They're asking find out the empirical formula. They're asking find out the empirical formula. How we can find that? We know that they have given the mass of carbon dioxide, right? They have given the mass of carbon dioxide. Since they have given the mass of carbon dioxide, we can identify the number of moles of carbon dioxide. Mass divided by the molar mass. What is the molar mass of carbon dioxide? Molar mass of carbon dioxide is very easy. Carbon 12, oxygen is 16 into 2. So that is 44. 44 grams per mole. That's the molar mass of carbon dioxide. And H2O. So these things are really easy. You know how to calculate the molar mass of water. Molar mass of water is 1 into 2 plus 16 grams per mole. That means 18 grams per mole. So this is the molar mass of water. Then when you divide the mass by molar mass, you can obtain the number of moles. Grams will cancel off here. 1 and here. 176, is it divisible by 44? Yeah, it is divisible by 44 because 44 multiplied by 4, then the answer will be 6, 1. Yeah, so this is 4. That means 0.04 moles of carbon dioxide will be there. Now you can understand here water. How much of water molecules are there? Mass is given as 1.08 grams. What is the molar mass of water? 18 grams per mole. grams will cancel off. Then the answer will be 18. 108, 18. So this one will be how much? 5, 6. If I multiply this one by 6, what will happen? 8, 4, 118. This is also divisible. That means 0.06. That means 0.06 water molecules will be there. Students, look at this one. Very easy, right? They have given a hydrocarbon is burned. The mass of the carbon dioxide obtained is 1.67 gram. 1.76 grams, and the water obtained is 1.08 grams. And then we can find out the carbon dioxide moles and water moles in this way. We know the carbon dioxide moles and we know the water moles. If we know the carbon dioxide moles and water moles, can't we take the ratio? Because we know that stoichiometry ratio means N carbon dioxide divided by N water. What is that one? That is equal to X over Y over 2. Right? X over Y over 2, which means 0.04 moles divided by 0.06 moles. Right? We can take the stoichiometry ratio. Stoichiometry ratio is equal to the mole ratio. Moles will cancel off. Here 4 and 6, that means here 2 and here 3. Right? Then you can obtain here 3x equal y, because y over 2 multiplied by 2. Right? Take this, you can put the cross product. Then you will obtain 3x equal y. Here you will obtain 3x equal y. Then take the x and y ratio. X over y ratio is equal to what? So that is equal to 1 over 3. X y ratio is 1 over 3. That means you can understand the formula of the compound is C1H3. That means CH3 is the empirical formula. We cannot simplify this one further. Empirical formula means the simplest integer ratio between each element in a particular molecule. So this is the empirical formula. This is the simplest form, CH3. So that answer will be third one. Question number 3, answer will be third one. Any doubts? Anything? Understood? Hafsha, Imad, Madhuri, Mariam, Miriam, Ranjula, Zara. Do you have any doubts? Can you hear me? Do you have any doubts? First of all, right, okay. I got the carbon dioxide mass, water mass they have given. Then I have found the number of carbon dioxide moles, water moles, and I have taken the ratio. From the ratio, I can obtain XY ratio is 1:3. So XY means actually number of carbon atoms and the number of hydrogen atoms accordingly. So the ratio is 1:3. That means formula is CH3. So then we don't have to use the mass of hydrocarbon given, right? No. If you want, you can use that one. Doesn't matter. Hydrocarbon mass is also can be used, but that's not necessary. Okay, that's not compulsory. If you want, you can use that one also. Okay, Nether. Right. If you use that mass also, you will get the same answer. Right, okay. So this is the third question. This is the third question. Right, now I'm moving to the fourth question. Fourth question. Fourth question. Let's see. P cubic centimeter of 2 moles per cubic decimeter HCl. P cubic centimeter of 2 moles per cubic decimeter HCl. Aqueous solution is mixed with sorry, P cubic centimeter of 3 moles per cubic decimeter HCl solution. Right? These two solutions are mixed. And they're asking the concentration of HCl in the resultant solution that obtained as the mixture. This is the mixture. Right? So this is the mixture, HCl again. Right? So what is the total volume? What is the total volume? V plus V, the total volume is 2V. V plus V, total volume is 2V. Right? You are going to mix these two solutions, HCl solutions. The total volume is 2V cubic centimeters. Okay. And they're asking, what is the concentration? What is the concentration of this solution, new solution? What is the concentration of new solution? They're asking this. How we can find the concentration of new solution? That's very easy. First of all, we know the volume, right? Since we know the volume, in order to find the concentration, we need to have the number of moles. Remember, concentration is equal to the number of moles divided by the volume. In order to find the concentration, we need to have only two parameters. We should know only two parameters, number of moles and the volume. Number of moles and the volume. We know the total volume. Total volume is 2V. So V is unknown factor. V is unknown value name. Yeah, in the question they have given V name. So therefore we can take that one as V. So the total volume is 2V in the new solution. V mixing with V HCl solution mixing with another V cubic centimeter of HCl solution. In the resultant solution's volume is 2V. You have to understand that. Then same compound HCl, we need to find the concentration. Right? Now let's see. First of all, I'm going to calculate. Let me take, this is the first solution and this is the second solution. Number of moles in the first solution, N1. Right? We know that when you multiply the concentration by the moles, concentration by the volume, you can obtain the number of moles. V into 10 to the power minus 3 cubic decimeters. Then you will obtain 2V multiplied by 10 to the power minus 3 moles. That is N1. Right? And here you can find out N2. Concentration is through 3 moles per cubic decimeter. Volume is V cubic centimeter. That means V into 10 to the power minus 3 cubic decimeters. Then you will get the answer here. 3V into 10 to the power minus 3 moles. Right? You can understand now the number of moles. The number of moles in the first solution is 2V multiplied by 10 to the power minus 3. Number of moles, total number of moles in the second solution is 3V multiplied by 10 to the power minus 3. Then in the resultant solution, what is the total number of moles? Total number of moles will be 2V multiplied by 10 to the power minus 3 plus 3V multiplied by 10 to the power minus 3. Then the value will be 5V into 10 to the power minus 3 moles. So these are the number of moles. These are the total number of moles exist in the resultant solution. Then we can find out the concentration. How we can find the concentration? HCl new concentration is equal to number of moles 5V into 10 to the power minus 3 moles. We know that concentration is equal to number of moles divided by the volume. What is the volume? New solution's volume is 2V. 2V, in order to convert this one into cubic decimeter, I'm going to multiply this one by 10 to the power minus 3. 10 to the power minus 3, 10 to the power minus 3 will cancel off. V will cancel off. Then the answer will be 2.5 moles per cubic decimeter. Concentration of the new solution is 2.5 moles per cubic decimeter. Right? Can you understand what I have done? Very easy. Only you have to do here, you have to play with this equation, C equal N over V. If you know how to deal with this equation, this calculation will be very easy for you. Neither. We know that C equal N over V, concentration is equal to number of moles divided by the volume. In the first solution, they have given the volume and the concentration, then you can find out the number of moles. In the second solution, they have given volume and concentration, then you can find out the number of moles in the second solution. Then in the resultant solution, the number of moles, total number of moles will be the summation of these two. You know the total number of moles, you know the total volume of the resultant solution. Then when you divide the total moles by the total volume, you can obtain the concentration of the new solution. That's all, very easy. Anyone didn't understand this? Anyone? Amani, Devindi, Hafsha, Madhuri, Maria, and Miriam, Ranjula, Zara. Do you have any doubts? Raise your hand who understood. Raise your hand who understood. Yeah, what happened to Devindi, Hafsha, and Mariam? Okay, right. So if you have any doubts, please ask me. I will guide you, right? So this is the way of finding the concentration of research. Remember, these calculation questions are very easy. Actually, just now in my theory class, currently we are doing the chemical calculation. So within a few weeks, chemical calculation will be finished. And sometimes some of you have finished the chemical calculation a bit earlier. It doesn't matter. So mostly these chemical calculation questions, the practicing chemical calculation will be very important for the other physical chemistry units as well. What are the other physical chemistry units? Especially chemical equilibrium. Physical chemistry, the longest unit that we have. We have to learn that one in grade 13. But remember, most of the calculations are depending on the chemical calculation third unit questions. So therefore, do these simple calculations first of all, and then later, little by little, we are going to discuss some difficult calculations. Keep that in your mind, right? These things are very easy calculations, right? Don't worry about these calculations. Little by little, you have to practice these things. Okay, so we are going to discuss every day a paper. So therefore, every week a paper. So therefore, don't worry. Okay, practice these questions again and again. Right. Number 5. Number 5 is regarding the density and everything. Following information are given in the label of a commercial bottle of acid. Normally, we know that most of the solutions are commercially available when you go for buying a solution. So in the solutions, in the bottles of those solutions, chemical solutions, they have mentioned the density. Sometimes they have given a mass percentage, right? Molar mass, right? And everything. We need to find out concentration or any other parameter. So this is kind of a question like that. Following information are given in the label of a commercial. So for the previous question, answer is number 3, right? For the fourth question, answer is number 3. Now we are going to discuss the 5th question. Following information are given in the label of a commercial bottle of acid. W over W, weight percentage is 92. Density 1.25 grams per milliliter. That means 1.25 grams per cubic centimeter. And the molar mass is 92 grams per mole. 92 grams per mole, right? What is the volume of this acid that should be used to prepare 400 cubic centimeter of 2.5 moles per cubic decimeter, right? They have asked us, what is the volume of this acid that should be used to prepare 500 cubic centimeter of 2.5 moles per cubic decimeter, right? Now, this is the solution we have to prepare. Remember, this is the solution we have to prepare. Volume is 500 cubic centimeter and 2.5 moles per cubic decimeter. First of all, I don't know what is the concentration of this solution, right? Now, this is the solution. This is the chemical bottle that we bought. Now we have to find, first of all, we have to find the concentration of this solution. They have given the density, weight percentage, and molar mass, right? So they have given weight percentage, density, and the molar mass. Then we can find out the concentration. How we can find the concentration? Remember, since the density is given, I will find out mass of 1000 cubic centimeters or 1 cubic decimeter in solution. Mass of 1000 cubic centimeter in solution. What is that one? The density says that mass of 1 cubic centimeter of solution is 1.25 gram. Therefore, mass of 1000 cubic centimeter will be 1250 grams. 1250 grams is the mass of the 100 cubic centimeter, if not 1 cubic decimeter solution. Remember, mass of 100 cubic centimeter, 1 cubic decimeter solution is 1250. Then we can find out, they have given the mass percentage. Mass percentage is 92%. Just imagine this is a sulfuric solution. Sulfuric. For example, I'm considering this is sulfuric. So this is the solution. This is the solution mass. But I need to find out what is the mass of the exact mass of sulfuric, right? So therefore, I will write down here mass of chemical compound in 1 cubic decimeter or 1000 cubic centimeters. So 1250 grams multiplied by 92%. So this is the mass. And they have given the molar mass, so therefore we can find out the number of moles of that chemical compound in 1 cubic decimeter, number of moles. So we can divide the mass by molar mass, then you can obtain the number of moles. Grams will cancel off. Here 0 will cancel off. 92 will cancel off. Then the answer will be 12.5 number of moles. Look at this one, how I have done the calculation, right? I'm going to explain this one again from the beginning. Weight percentage is given as 92. Density of the solution is given as 1.25 grams per cubic centimeter. Molar mass is given as 92 grams per mole, right? That means if I have taken 1 cubic decimeter or 1000 cubic centimeter of the solution, mass of that solution is 1250. But I need to find out what is the exact mass of the chemical compound inside the solution. For example, just imagine we have taken sulfuric aqueous solution. So sulfuric aqueous solution is made by sulfuric plus water. So therefore, solution means sulfuric plus water. So is the other 8% is solution of water? Yeah. Other percent is actually water. 92 is actually sulfuric chemical compound that we are going to consider. So therefore, mass of chemical compound in 1 cubic decimeter should be obtained by multiplying 92%. So that's what I have done here. Then you know the exact mass of sulfuric. Then we can obtain the number of moles of sulfuric by dividing the molar mass. So this is the number of moles. Now we can know, now we know that what is the concentration of the solution? What is the concentration? Concentration, look at this one. They have given that, right? We have considered 1 cubic decimeter of the solution, right? In this question, we have considered 1 cubic decimeter. So concentration means number of moles containing in 1 cubic decimeter. So 2.5 moles are containing in 1 cubic decimeter. So therefore concentration is 12.5 moles per cubic decimeter. So this is the concentration of the solution. This is the concentration of the solution that they bought commercially. Look at this one. Concentration of this solution is 12.5. Students, they're asking here, they're asking to prepare this solution. They're asking us to prepare this solution. Using this solution, we have to prepare this solution. Right? Using this solution, 12.5 moles per cubic decimeter solution, we have to prepare this one. What is the concentration of the given solution? 500 cubic centimeter, 2.5 moles per cubic decimeter. That means, first of all, we need to find number of moles in the solution that they have given. Look at this one. They have given the concentration and they have given the volume. Concentration and volume. 2.5 moles per cubic decimeter multiplied by 500 cubic centimeter means half cubic decimeter. So cubic decimeter per cubic decimeter will cancel off. Then 1.25 moles is the number. Students, we need to prepare a solution with 1.25 moles. We need to prepare a solution with 1.25 moles. Then we have to take some amount of volume from the commercially available solution. The concentration of the commercially available solution is 12.5 moles per cubic decimeter. We know the number of moles. Then can't we calculate the volume? Can't we calculate the volume? We can calculate the volume. How we can calculate the volume? We know that C equal N over V. Then V equal N over C. Right? Volume equal to number of moles 1.25 divided by the concentration 12.5 moles per cubic decimeter. So the answer will be, what is the answer? 0.1 cubic decimeter. So that means 100 cubic centimeters. We have to take 100 cubic centimeter of volume from this commercially available solution, which is having the concentration 12.5, in order to prepare 500 cubic centimeter, 2.5 moles per cubic decimeter solution. Understood? Remember, we have to take 100 cubic centimeter of volume from the commercially available solution, which is having the concentration 12.5 moles per cubic decimeter, in order to prepare 500 cubic centimeter, 2.5 moles per cubic decimeter solution. Right? Sometimes some of the students are using this kind of a connection. C1 V1 equals C2 V2. Right? C1 V1 equals C2 V2. We know that CV product gives the number of moles. Yeah, that's correct. We need to have same number of moles from the both solution. They have given us to prepare this solution, right? 500 cubic centimeter, 2.5 moles per cubic decimeter solution. So there is a certain amount of moles thing. So that exact moles will be in the solution that we are going to take commercially. So the same number of moles should be there. So therefore, what they have done, concentration volume product should be equal to the concentration volume. From this one also we can find out the volume is 100 cubic centimeter. So the calculation that is up to you. So the answer will be third one again for the question number 5. Question number 5, answer is third one. Anyone didn't understand? Raise your hand who didn't understand. Raise your hand who understood first of all. Okay, right. Right, okay. Then, so this is the end of the rim paper 24. So I will first of all stop the recording.